Welcome, ladies and gentlemen, to Precalculus Foundational Skills, week number 1, where myself, Mr. McLogan, is here to get you prepared for precalculus. So let's kind of get started here with a precalculus tip, because again, that's the general purpose of these live streams that I'm doing. And for those of you that have not taken precalculus before, hopefully you're not retaking it. But one thing that's interesting about precalculus is that it is a very segmented course. Everything, a lot of people always go with, well, once you learn something in math, like it just builds on it. And that is true for precalculus, but it's not absolutely true. Meaning, a lot of precalculus topics can be taught in a different order. And, some teachers might teach it one way, other teachers might teach it another way, and you don't have to go chapter 1, chapter 2, chapter 3. We can actually move things around to teach the course to better suit maybe our students or our teaching styles. There's many things over the last 11 years that I have taught in precalculus that I used to teach, I don't teach anymore, or maybe I might teach in a different order. And the reason why I'm bringing this up as a tip is because if you struggle in a concept or in a chapter or on a test, that does not mean that you are going to struggle for the rest of the year, right? A lot of times, in other courses, a lot of students think, oh, well, if you don't understand this, you're not going to understand the rest of the year. Well, in precalculus, that's not always going to be the case. So what I always recommend with students as a tip is, yes, when you're struggling, just keep on working. You can always come back to that material and learn it, but it does not set you up for failure for the rest of the year. So just make sure you understand that segmentation of precalculus. You can always go back and learn a lot of those concepts, because even though they are woven together, they are not necessarily going to be foundations off each other. And also, that's why I'm here, right? To kind of get you those foundational skills. Now, the goal of this first kind of live stream, guys, this live stream series is really just to build those foundational skills and to give you guys the confidence. So I've been teaching math for, over 10 years now on YouTube and over 14 years inside of the classroom. And especially in precalculus, but in other courses, I see where students struggle. I know almost every year it's like by prescription, oh, this student is having trouble with these problems or in these chapters. And I can always revert back to these workbooks that the students are doing, and also that the skills that I know that they need to have before that. And one of the big things that it comes into is the more you practice, the more confidence you're going to get. So my goal here is to not only just help you with some of the problems that students maybe make mistakes with, but also to allow you to keep on working on those. So therefore you have more confidence, because we all know last year did not end the way that we all thought it was going to end. So building up some of those skills is going to give us confidence when we start this new year. All right, so for this live stream, I'm going to cover kind of 5 topics that I just feel like there's a good foundational start to taking precalculus. And that first one is functions. Now, when we're looking at functions, a lot of times we can see a function as a graph, we can see it as an equation, as a table, as a mapping. I'm going to work with functions as a set of points. And again, remember, functions can basically be given a name, like f of x is our most common. We could also say, maybe g of x. And again, really the f and the g is just a way for us to differentiate the names of the functions. Like these are obviously do not have the same points, so they are different, right? Now, a couple things to understand with a function here is that we want to understand that the function has an input and an output, and that is very, very important. You can see that each one of these points is a x and a y coordinate. Now, I'm just going to go ahead and plot these so we can kind of explain what it actually is, what's important about that function. So if we get -3, 2, we've got 0, 0, and +3, 2. Now, hopefully you kind of see that this looks like a little parabola, which it is if it was connected, but this is a discrete function. It's just a set of points. Now, the important thing to understand if a set of points, an equation, or a table is a function, that means for every input has exactly one unique output. So you can see here that -3 is what we call our input. And when we plug -3 into our function, that's going to give us our y coordinate, which is our output. So you notice that there is no other -3, right? And this input 0 outputs a 0 for the y. this input 3 outputs a positive 2 for the y. Now again, negative 3 and positive 3 both have the same output, but again, that's okay. As long as the same input does not give you two different output, it is a function. And the way that we can represent that is using, or look at that, is using what we call the vertical line test. So a lot of times when we're looking at a function, you can just take any vertical line, and if you move that vertical line across your function, as long as it doesn't pass through two different points for the same line, then you're going to have a function. So this would be exactly a function, where again, f really represents the name, x represents the input, and then this expression either is going to represent the expression of the function, or it can represent the output value, depending on how we're dealing with the function for our notation. Now, in this next example, let's just call this g of x here. Let's go ahead and plot this. And this one kind of comes into the important that we have our input and our output, right? We have our x and our y. Now, the important thing I want you to automatically recognize here, though, is I have the same x, which is my input, and I have two different y's. Now, look what happens when we go ahead and graph this. 1, 2, 1, 2, 3, 0, and then 2, negative 3. You can see here, if we were going to go ahead and apply the vertical line test, that this line, vertical line, would now pass through both of these points at the same value. So this is actually not a function. All right, and you can look at that graphically because it doesn't pass the vertical line test, which usually a lot of students like to prefer. But in reality, the main idea here is that you have an input that has the same output, and that does not follow our definition of a function. And this is really important because in precalculus, almost the majority of the class, we are going to be dealing with functions. So it's very, very important to make sure you understand the general notation of the function, you understand the input and the output, and when something is going to be a function or not. All right, the next thing is we're going to cover a lot of equations, and we're going to get to some pretty advanced equations. And it's pretty difficult to understand solving equations if you don't remember the very, very basics. So this first equation is, yeah, I know, it looks pretty easy, or it is pretty easy, right? You're just going to use inverse operations. The main idea I want to bring to you, though, is that there's only one variable, right? It's just an x. So when you just have one variable to solve for, you can just use your inverse operation. So, you add a 1 to both sides, 2x equals 1. And then you divide by 2, and x equals 1/2. Fairly simple, right? In this part B, you can see, hey, this is also an equation. It's a quadratic equation, but there's only, again, one variable. Now, the variable is being raised to the second power, so we're just going to have to use our inverse operations to undo the squaring, which would be using the square root. So, again, we'll just use our inverse operations to isolate the variable. Then we'll divide by 2. And again, remember, you're using the reverse order of operations. The inverse operation of squaring is going to be the plus or minus square root. Don't forget the plus or minus. This is one of the big mistakes students make. Didn't really mean to get into the simplifying here of your radicals, but just remember that you can break up a square root is the square root of 1 over the square root of 2, which would be plus or minus 1 over the square root of 2, and then you could rationalize the denominator, okay? So therefore, we get a final answer of square root of 2 over 2. So not really what I was, that is something that we'll definitely get into later in with this chapter. But my main goal here is just to solve. Like even if it was non-simplified, this would be fine. The important thing is most students are okay when there's one variable. But what happens when there's now two variables going on here? Well, a lot of students will make the mistake and they'll say, well, let's just do what we already did and let's divide by 2. And the question and the answer is no, don't do that. We have two variables. We have to come up with a different method for solving. And there's a couple different ways we could do this, completing the square, quadratic formula. But the best choice to always look for first would be factoring. Now, the only reason why factoring is preferred is because of what we call the zero product property. See, factoring takes an expression and rewrites it as a product. And when you have a product equal to 0, then one of those products or one of those expressions has to equal 0 via the zero product property. So what I'm going to do is I'm going to set this equation equal to 0. And I'm going to do that by subtracting the x to the other side. Now I'm going to factor it, basically factor out what they have in common, which in this case is a x. And then I'll have a 2x minus 1 equals 0. Now you can see that I've taken my expression, I've rewritten it as a product, and now I can just apply the zero product property. So x equals 0, and 2x minus 1 equals 0. Let's just use the inverse operations we already knew here. So x equals 1/2. And you can see that I have two variables here, or at least this is power to the second. And you can see that I have my two answers. And here I have the plus and the minus, which, don't want to forget that plus and minus. All right, so for the next one, again, now students are like, all right, I got the factoring down pat, so let's just factor this. And it's like, no, because there is no the two product. You have to have that expression equal to 0. And if you subtract the 2 over there, that doesn't work either, because now the expression is not written as a product equal to 0. So to apply the zero product property, we have to have our expression written as a product, okay? Equal to 0. So it has to be equal to 0 and it has to be written as a product. So let's just go ahead and erase all of that because that does not count. Okay, so then what are we going to do? Well, the first thing we're going to want to do is obviously get our 2 to the other side because we want it equal to 0. So I'm just going to say plus x minus 2 is equal to 0. Now, the next thing we're going to do is factor a trinomial. And trust me, guys, we're going to be doing a lot of factoring practice. Actually, next live stream, I'm going to even do more factoring problems. So for right now, I'm just going to keep this fairly basic. And basically, what we want to do is be able to factor efficiently. So I definitely do have some additional topics for you guys to get good at factoring, that if you need more practice ahead of the year. But for right now, hopefully you guys have a decent foundation of factoring. So therefore you can look at this and say, what two numbers multiply to give you -1, add to give you 1. You know that this is a trinomial. So therefore all trinomials can be factored into a product of two binomials. So in this case, it would be, let's see, there'd be -2 or +2, I'm sorry. -1. And again, you can always check my work by actually multiplying this back out, which we're going to do later. But now you can see this expression is a product equal to 0. So now you can just set each product or each expression now equal to 0 and go ahead and solve. And there you go. That is your solving equations. A lot of people will not know the difference between these equations and see how each and every one of these equations had a different process. They're very similar to each other, but they were different. And a lot of times students will confuse them or will confuse their processes between them. Now let's get into multiply expressions. So this kind of gets back to that, like, how do you check your work on multiplying expressions? Well, again, remember the FOIL. We don't really like FOIL because obviously we're going to get into dealing with, binomials and trinomials and polynomials with 4 terms. So you're going to want to expand beyond just a binomial times a binomial. But it is important to kind of remember, like, what happens when you have an expression times an expression, right? That's separated, or a binomial times a binomial. That's separated by addition and subtraction. Well, what we need to do is make sure that we multiply everything by everything, okay? So you can see I'm basically applying the distributive property for both of these terms, all right? And again, that works because these terms are separated by subtraction, right? So that's why we need to apply that distributive property. So you can just do this individually, and then we have, so like 2x times x is 2x squared, 2x times 1 is going to be a positive 2x. -1 times x is a negative x, and -1 times 1 is -1. Just remember, though, now to simplify our expression, we can go ahead and combine like terms. So 2x squared plus x minus 1. You can see that the product of two binomials gave us a trinomial, right? And again, what was factoring? Factoring, which we did in the last problem, was just taking our trinomial and rewriting it as a product. So it's just that reverse operation. Now, on the next example, it looks pretty confusing, but that's because I wanted to cover a couple topics here. So first of all, when we're multiplying rational expressions or fractions, you're just multiplying numerator times numerator, denominator times denominator, okay? When we're multiplying radicals or even expressions, you can see that these expressions, that's 3 times the square root of x, right? So we don't need to apply distributive property like we did here because the 3 and the square root are separated by multiplication. So what we're going to do is we're just going to multiply this quantity as a whole times this quantity as a whole. Now, how do you multiply square roots, or when you have square root expressions or radical expressions? Doesn't really matter if it's a square root or not. Well, in that case, you're going to multiply the coefficients by the coefficients, and the radicand, what's the expression under the radical, times the radicand, the expression under the radical. So we also have a negative here, which I'll explain here in just a second. So let's just kind of do the math, and then we'll figure out where we want to do with this negative. So in this case, we're just going to multiply the 3 times the 2. Let's just do it here. So that'd be 6, and then x times the square root of x minus 1. Oops. So x times x minus 1. Okay? And then in the denominator, I can just multiply this x times x minus 1. Now, a lot of students will make the mistake and thinking that these square roots will multiply out, and that's not the case. So we're still keeping that function. It's just you're going to be multiplying the radicals. Or multiplying the radicands, I'm sorry. The other thing is, notice that we have the same expression in the numerator and denominator. Typically, that means we would divide that out, right? But we can't do that because this is under the square root and this one is not. So therefore, we cannot just go ahead and simplify them. We also have this negative here. I'm just going to keep this in front, and then I will show you where it can go. Okay, we can simplify this though a little bit more. So 6 square root of, let's apply distributive property here. So that'd be x squared minus x all over x squared minus x. Okay, so I just distributed the x. Now, where can this negative go? Well, what if I had negative 4 divided by 2? Okay, negative 4 divided by 2, we know that's equal to negative 2. Agreed? But that's also equal to negative 4 over 2, which is also equal to 4, hate 4s, 4s over negative 2. So if you notice, it doesn't really matter where the negative is. It can be in front, top, or bottom. Just do not put the negative in the top and the bottom, because that is equal to 2, right? And we need this to be a negative 2. So I'm just going to leave it in front, but if you were to put it in the top or in the numerator or the denominator, that would work as well. The other thing is you cannot take the square root of x squared here. We cannot take the square root of two terms separately when they're separated by addition and subtraction. Again, that's that difference here of when you have terms separated by addition and subtraction, you cannot take the square root of them separately. When they are separated by multiplication or division, you can do that. So if you remember in the first example where I had the square root of 1/2, I can distribute that square root to the 1 and the 2, and that's because they were separated by division, not subtraction or addition. So just wanted to kind of make that point for you guys. All right, the next one is a quadratic formula. So a lot of times students struggle with factoring, and we're going to have problems that are non-factorable. We're going to deal with irrational numbers. We're going to be dealing with complex numbers. So the quadratic formula is going to be very helpful. And where a lot of students get hung up on this is they don't remember the quadratic formula, or they might remember it, but they make a mistake using the order of operations. So let's just kind of do a quick little review of the quadratic formula. X equals opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. Now, this a, b, and c is all from the quadratic equation in standard form equal to 0. So that's ax squared plus bx plus c. Okay, so in this case, I have a quadratic function, an equation here, but it's not equal to 0. Well, basically, to make it equal to 0, we can just replace y with making it equal to 0. Okay, so we can just say, basically, all right, well then 0 is going to be our output. And basically what that means is we're trying to find the x-intercepts. That's what the quadratic formula is going to give us. You know, if we were to graph this, remember at the beginning of this live stream, I said x and y, right? X represented the x-coordinate, y was the y-coordinate, and that told you, where to plot those points. Well, that's the same thing for this equation here. These are going to be your x and your y coordinates, and it is a function. But if what we're trying to find when the quadratic formula is, if we set y is equal to 0, well, that means we're trying to find the x-intercepts. And that's exactly what we'll use for the quadratic formula. Now, obviously, sometimes that might be, instead of actually looking for the x-intercepts on the graph, we might be talking about the zeros of the function or the roots of the equation. It might be framed differently as far as why we're using the quadratic formula, but it's all basically the same. So now that I have my standard form equal to 0, all right, you could look into factoring this, but let's just say we're going to do the quadratic formula, so let's just go ahead and get to it. So first thing we want to do is label our a, b, and c. So a in this case is 2, b is 3, and c equals -1. Now, all we're simply going to do, guys, is just plug and chug. Just plug those values into there. So I have a -3 plus or minus the square root of 9 minus 4 times 2 times -1. All over 2 times 2. Okay? And when I just go ahead and simplify this, now again, this is me writing everything out. And why did I write 9? I should do this. Sorry. I said I wanted to do this slow. So that's 3 squared. So I have 3 squared, and so you go ahead and 3 squared is going to be 9. So let's do this one by one. So you're always going to want to do this one first here. And then we have a -4 times 2 times -1. Okay, so even though it says minus 4 times 8 times c, just treat the 4 as a negative. So if we have a negative number, we are going to write that as a, minus 10 or whatever. If it's positive, then we're going to add that number. But in this case, when we take a -4 times 2 times -1, that's going to give us a positive 8 over 4. So now we can say under our square root here is -3 plus or minus the square root of 17, which we cannot simplify any further, divided by 4. Now, when we're writing depending on how we're writing the answer, you could also maybe distribute that 4 to both of these terms. So you might also see an answer like this, square root of 17 over 4. So just another way you guys can see how that answer could be written. All right, and on to the last topic, ladies and gentlemen, is completing the square. So many students do not like completing the square. They forget completing the square, and they just don't want to do completing the square, which I totally get. Now, you could use completing the square to also solve instead of the quadratic formula. I wouldn't replace it for factoring unless you like really bad or really bad at factoring. But we're going to use completing the square primarily in this course to help us rewrite an equation that was in standard form, which we just did, ax squared plus bx plus c, into vertex form, which would be y equals a times x minus h, quantity squared plus k. And the point that we're going to want to do from this is the vertex form is much easier for us to not only graph the function, but also for us to be able to identify the characteristics, like the transformations of that function. So the important difference between standard form and vertex form is this binomial squared. Now, hopefully you recognize that binomial squareds come from a perfect square trinomial. So let's go and look at this first equation because it's kind of like an easy one to understand completing the square. So let's pretend we forget how to complete the square. And we just say, well, if I wanted to factor this, or I recognize this is a perfect square trinomial, I can factor this as x minus 2 times x minus 2, right? Which is y equals x minus 2 quantity squared. And guess what? I just completed the square, right? Kind of. I took it from standard form into vertex form. But basically, main thing is it is now written as a binomial squared. So when you have this perfect square trinomial, you can easily factor it into a binomial squared. Now we look at the next example, and we recognize this next example is not a perfect square trinomial, right? So what we want to do is what we call find the value c. So what number could we add to this equation that would make it a perfect square trinomial? Now, if you're really good with your factoring, which is the point that I want my students to get to eventually, you can be able to do this in your head. Most students cannot do this in your head, so they kind of need like a little formula to remember to find this value c that creates a perfect square trinomial. And that little formula is b divided by 2 squared. So if we took 6 divided by 2 and squared it, we would get 9. So 9 is the value that creates that perfect square trinomial. So y equals x squared plus 6x plus 9. Okay, now again, the problem is though, this was already a perfect square trinomial. This is not. So you just can't randomly add a number 9 to an equation, right? Because remember equation, whatever you do on one side, you have to do it on the other side. Now, you could add a 9 to both sides, but in this case, I'm going to add a 9 and subtract a 9, right? Because it's really the same thing. That's just undoing each other. But the reason why I want to do that is because I want this x squared plus 6x to be together. So I'm going to group it. All right, and then I recognize that is a perfect square trinomial, which can be written as x plus 3 quantity squared minus 9. All right, guys, in the last example here, I have y equals x squared minus 8x plus 5. Same kind of thing here. This is not a perfect square trinomial. And I already have a number here. So here I had to like make up the number, right? I had nothing. But here I already have a 5. So what I'm going to do in this case is I'm just going to like kind of forget that 5 is even there. I'm just going to say, well, let me just look at these first two terms. Oops, let me put the c there. And then I'll put the 5 on the outside. Okay, so again, now we want to do, all right, so we take -8 divided by 2 and square it, right? So -8 divided by 2 is -4, -4 squared is 16. So y equals x squared minus 8x plus 16. And then again, be careful. Once you add it, just make sure you immediately subtract it to keep the equation equal. And then plus 5. Now again, we have our perfect square trinomial, and in this case we have x minus 4 quantity squared minus 11. And there you go, ladies and gentlemen. That is how you complete the square to rewrite your equation from standard form to vertex form. So as we kind of wrap up this live stream, let's kind of talk about, and don't worry, I still have one more kind of tip to give you, is what did we really learn today? So in review, we really kind of learned, again, we talked about functions, what is a function, and the notation of a function, and understand when is a function. We talked about the solving equations, the different ways we can solve an equation, at least when we have one or two variables, and how to apply inverse operations as well as factoring. Then we talked about the different ways to multiply some different types of expressions, as well as how to simplify those expressions, how to plug in values for the quadratic formula to solve, as well as completing the square. Now, one of the common questions I get with students, especially at the beginning of the year, is I just understood everything that you just covered today. Do I really need to do the workbook? Or I'll even have some students like, should I probably test out a precalculus? Like, you just covered some very basic stuff. Like, I think I'm like, do not really need this live stream or this course. And my answer to that is please absolutely get to work doing the stuff. Because the thing about precalculus is it exposes what you know and what you do not know. And a lot of students come from different courses having a good grade and understanding the material, but they don't really know how well they understood the material. They got really good grades and they felt like they knew what they were doing, but when they come into precalculus, they really get challenged to making sure that they know that stuff very, very well. And that kind of comes into, again, what I talked about is that confidence, right? Once students start getting maybe some problems wrong, they start losing that confidence. They start to second guess, do they have the ability to really continue on with this course? And the answer is absolutely, but you got to make sure you're putting in the work. And that's why I've created this workbook for you guys, is to go through those problems, practice them, make sure that you have that foundation, because as you begin the year, you're going to get stuck. There's going to be times where you're like, I forgot how to do this, or I'm not sure, I know how to do this, but maybe I don't know how to do this one question or this one problem. So really having a solid foundation of practice and of understanding is going to set you up for success on the next thing.